Hello, welcome to this quick tutorial video on soldering. I'm going to emphasize some of the important points here as we work, just to kind of show you like things you need to do. All right, so we're going to start out with a few quick safety things. The first is I have here an air filter, right? You'll find these in the lab. And when you start soldering, you should probably turn it on, right? It's just going to suck in some of the smoke that comes off of soldering and filter it through a HEPA filter. Now, I will say that the smoke from soldering is actually not particularly harmful, but it's also not like great to breathe in smoke in general. So it's a good thing to run it, but don't like freak out if a little bit of the smoke escapes the filter. It's not that big of a deal, right? But in order to turn it on, there's a button over here on the side, and you click it 3 times to put it onto the highest power. For this video, I'm not going to turn it on, and that's only because the sound of it overpowers the microphone, and then that causes us some issues here. The next thing I want to point out is I have my soldering iron here and the stand has a sponge in it. This sponge should be damp. Damp means that it's wet but not dripping. And so in this case, like what I did is I took it into a sink, I got it wet, and then I wrung it out really, really good. I squeezed it until I couldn't get any more water out. So at this point it's damp, but like I can't squeeze any water out of it. We're going to use the sponge to kind of clean off the iron as we work, and the sponge has to be damp. If it's dry, all you're doing is melting sponge onto your soldering iron and ruining the tip. If it's too wet, then it will like cool down the iron too much as you work, and that can cause damage to the iron as well. So just damp is perfect. The other thing I want to note is that these particular soldering irons are temperature controlled, which is really nice. These are fancy irons, right? And when you first turn them on, click on here, it'll tell you what temperature it's set for. This one's set for 699. You can adjust that temp by changing this dial to pick a temp. I'm going to start at 650. Lower is usually better to get started. Now, after I move off, it's going to tell you the current temperature of the iron as it heats up. So we'll go ahead and let that heat up. It's back here. So I have here a circuit board that I've been working on, right? And my plan is the first thing I want to add is the Raspberry Pi Pico here. And so the way we're going to do that is with some headers, right? So we have these little headers. And in the end, these headers are going to go in here, get soldered on, and then I'll plug the board into it. I'm going to use this nice stand to hold my circuit board in place. It's not that complicated to use, but like you kind of, well, got to loosen this part up. There we go. And I'm just going to slide this in place. Boop. Put a little bit of pressure there, and then just clamp just to hold it. Now I have this guy, which I can choose to loosen and tighten using this screw with kind of the spin to it. But okay, so I have these headers, right? And my ideal is that these headers will go into these holes here, kind of get them to lob in there. Then I'm going to solder them from the other side. Drop one in just to give you an idea. So those headers are going to drop on, and then in the end, I'm just going to like put my Pico in. Now, because we have 2 and they're lined up, like there's a little bit of sideways give on these, and if I were to solidify them in place a little bit too far out or a little bit too far in, then the Pico wouldn't plug in properly. So actually the easy and lazy way to fix that is to pre-install the headers on the Pico and then put it all in place and then solder it from there, right? So I'm just gonna put these in place and put this in place. There we go. I'm going to make sure that I have it lined up. In this case, the debug port's towards the back here. And I'm just going to put it through the holes that are pre-drilled on the board. Could be that I have to kind of finagle it. There we go. Now, ultimately, I'm going to spin this thing over, right? I'm going to solder these pins here. Now, the problem is if I spin it over, it might fall out. It might stay in too, but it might fall out. And a nice, easy way to kind of handle that. Have you ever seen blue tack, this kind of stuff? Sometimes you use it to like put posters up on your wall or whatever. A little bit of this can be super helpful for trying to hold things in place, especially initially. So what I'm going to do is I'm going to pick 2 corners where I'm going to be like, these are the 2 corners that I'm going to put some blue tack on to hold it in place. But then when I solder, I'm going to first solder the other corners so I don't heat up the blue tack. And then I can pull the blue tack off and the 2 soldered joints will hold it. So I'm just going to stick a little bit of blue tack here on that side. A little bit of blue tack here on this side. And I'm going to spin it over. Zoom in a little bit so you can see what we're looking at here. All right. So at this point, if I get on its side, you can kind of see the pins beginning to stick through. And that's what I want, right? Because when I do soldering, I'm basically bringing solder, which is this like meltable metal. It used to be made with lead. This kind's not made with lead, right? And when you heat it up, it melts. And your goal is to build a joint between the pin sticking out and the pad sitting there on the board. So I'm just trying to like get a little blob of solder to connect the pin and the pad. Now solder tends to flow towards heat, which is important to note when we go a little bit later. The other thing to know about solder is it does not do well when there's oxidization, when the metal is oxidized. Now, if you know anything about metals, they oxidize like fairly easily whenever you expose them to air. And so like all the metal you see here is already lightly oxidized and solder won't like to connect to it. So we use something called flux or soldering paste, just depends on what people want to call it, right? And what flux does is it helps remove that layer of oxidization on the top. So I'm going to use this metal brush and I'm going to very, very lightly put some on all the joints that I really want to do. So I'm just taking some. You don't have to be, you can actually be fairly generous with this stuff. In general, more flux is probably better because you don't want to try to solder things that are oxidized and don't have enough flux. The lazy way of thinking of flux is flux helps solder flow. So when we get the solder hot, the flux is going to be what helps us out. So I'm just going to keep painting this on. I'm painting carefully because this is a metal brush and I don't want to like damage anything here on the board, but the actual flux itself is fine to get quite a bit on here. If you get too much, you can always clean it off later, or just, honestly, most kind of flux you can just leave, but we'll just do this for now. Okay, so I've got that flux on there. Let me zoom back in so you can watch when I solder. Okay, so I'm going to check the bottom of my board here to remember where I put my blue tack, because I don't want to heat up the part of the metal that's above the blue tack, because I don't want to melt the blue tack. So I have blue tack here and here. So I'm going to solder this pin and this pin, the two on the opposites. And once I have two pins, then like the thing will be held enough in place that I can remove the blue tack and keep going, right? Okay, so I have my iron. And you'll notice that initially there's kind of a blob of junk on the end of it. That's because it was left that way on purpose to protect the iron from oxidizing. But what I'm going to do is I'm going to wipe that on my sponge, right? So I'm going to take my sponge here. I'm going to very, very lightly wipe that on my sponge because I already have my iron heated up. And my goal is just to kind of get the sponge cleaned up. Great. So there, I've got, or not my sponge cleaned up, my iron cleaned up. Okay, so I have my iron slightly cleaned up. I'm going to take some solder, and this is just a method thing. I don't like holding the whole thing, so I just rip a piece off. It's fairly malleable, so I just have a piece in my hand, right? Okay. Your first step is you're going to do what's called tinning the tip. Tinning the tip is where you put a little bit of solder onto the tip of the iron, kind of melting some solder on there, right? Now you can see that smoke I'm talking about, right? Just for the moment, let me briefly show you the air filter at work here. Sorry if my voice gets bad while the air filter is running, but if I melt a little bit more, let me wipe that off. If I melt a little bit more solder, you'll notice that the smoke is now pulling towards the air filter. That's probably for the best, right? But okay. So I have a little bit of solder on my tip. Let's zoom back in. Now the important thing is I'm trying to build these joins like I was talking about before. When I have flux on the pins, what you're going to notice is that actually when I just heat it up, some of that solder might flow already. But if it doesn't, I'm going to bring some in from the opposite side of where the iron is. Do you see what I did there? So I touched on the right side with the iron, and I brought solder in from the left side. So you're always going from the opposite side because we want solder to flow through the joint to the iron. Remember, solder flows towards heat. So if I'm heating up the opposite side, I bring in my solder, then I'm getting it in there. The other thing I want to emphasize is that I'm not just heating up the pin that's sticking out. I'm trying to touch the iron to the pin and the pad, right? And the point there is that if I get onto the pin and the pad, then I'm heating up both, and solder will connect to both. The other thing to note is that I'm trying not to keep the iron on there longer than I need to. a lot of electronics components are pretty good about handling heat, but like you really don't want to needlessly overheat them if you can avoid it. All right, okay, so I have a few there. So I did those. Remember, I was going to do a few down here as well, just to get it all in place. Kind of tacking it down. Boop. Boop. There we go. So I've got a few down on there. I'm going to stick my iron back over here in its cover. I'm going to flip this over. And I'm just going to remove my blue tack. Because I don't need it at this point. The few joints I've soldered are holding it all in place. So I'm just going to remove the blue tack. I'm not going to throw it away. I'm going to put it to the side because that's still very usable blue tack. Okay, flip this guy back over. And now I'm just going to solder more joints. I'm just going to solder all of them. Some things to pay attention to while you're soldering, right? You may need to occasionally clean your iron. I'm over here wiping my iron on the sponge right now, right? And then I'm just going to heat up the pin and the pad, add some solder, pin and pad, add some solder. Just going to kind of keep going, right, as I go. You want to make sure you don't accidentally bridge two pins. That's something that sometimes happens. Like while you're soldering, you end up with too much solder and you cause the solder bridge between two pins. Let me see if I can force that to happen here. There we go. So if you can kind of look, get my pointing device here. If you look here, you can see that I have managed to accidentally get too much solder and two pins are bridged. That would be bad. You wouldn't want to power up the device with those two pins bridged, right? So there's a few ways you can handle that. Probably the laziest way is I take my iron, I'm wiping it over here on my sponge, and then I'm just going to heat up a little bit. And I'm going to try to kind of pull off some of the solder onto the iron and then wipe it off on the sponge, right? And so you take a look over here, you're like, oh, it kind of looks like I got rid of the bridge. Just in order to make sure, I'm going to add a little bit more flux. Because flux helps solder flow, right? This might be too much flux. There we go. Add a little bit of flux there. And I'm just going to reheat that joint with the flux. And look, I got a little bit more solder on my iron, just kind of pulling it off of there that I didn't need on there. Wipe it off on my sponge. And reheat the joints around. Okay, that looks pretty good. Okay, let's just keep going. All right. Okay, you may notice that I'm beginning to run out of the solder that I ripped off. Don't burn your fingers to save 2 cents worth of solder. Instead, just go ahead and rip off yourself a new piece. So I've got a new piece. That little bit in my hand, I'm just going to let die. I'm just heating up pin and pad. Away I go. Just for fun. Get any closer without causing problems. No, this camera's not going to like that at all. Okay, we'll keep it about there then. It was a good effort. Okay. Still need to do. One thing I'll mention here is that you should wear safety glasses. You can't see my face, of course, because I'm on the other side of the camera. If you wear glasses, your own glasses are fine. Almost all prescription lenses are a polycarbonate of some sort that would be plenty safe for like something like this. The reason is that solder can sometimes bubble up and spit, we call it, and you would hate to get that in your eye. It would be very painful and potentially blinding. So you should wear safety glasses. You'll have a kit. You'll have a pair with every soldering station in the lab. Okay, just going through. You notice I'm really not spending much time on each joint. Okay? And it doesn't take like a crazy amount of solder either. What you're looking for is a joint that kind of looks, get this over here so you can see when I wipe actually. You're looking for a joint that appears almost like shiny and conical, like it's going to be kind of like looped up into a cone. You don't want it to be like oddly shaped or like something like that. That means that something went wrong in the soldering process and maybe you didn't get a good join. Okay. there, get a little bit more solder off of my spool. Wipe this guy. Tin my tip just a little bit. Keep going. All right, now I'm going to go through and I'm going to kind of inspect my joints. I'm also going to turn off my soldering iron. So I'm going to click the button on off just so that I don't leave it running needlessly. I'm going to kind of look on the side here. Hopefully I can get this zoom to do what I want. I'm going to kind of look and see, do I see the shapes that I like, right? Remember I mentioned kind of a conical shape. I know it's kind of hard to see here, but these are fairly conical. I'm fairly happy with those, right? Although this one here, I'm not too pleased with. It's not quite the right shape, and you might not be able to tell on the camera, but it's also kind of a dull color. That makes me think that that joint is not too good. So I'm going to redo that one. Power the iron back up. If I redo a joint, I'm just going to add a little bit of flux. And honestly, redoing a joint doesn't necessarily mean adding more solder. It might just mean heating it up. Right, so I'm going to wipe my sponge here. I'm going to tin my tip a little. Okay. Now that joint that I'm not too pleased with, I think was this one. I'll do the two around it as well, just in case. Yeah, that looks better to me. Great. So I'm going to do a quick inspection here on this side as well. I've got another one I'm not too happy with. It would probably be fine, but this one here, just looking at it, I'm not too pleased with it. So I'm going to put my tip on there. That one just looked like I didn't have enough solder. This one in the end also might not have. Maybe it did, and maybe I've oversoldered it. So, I think it's fine now. All right. So there, I've got that guy added. Let's zoom back out a little bit. Flip this thing over. Right. Okay, so I have my Raspberry Pi, and it's in the header. Now, interestingly, if I'm very, very careful with this, I can remove the Pico, and the headers stay intact because the headers are like deeply soldered in there. Right? So you don't have to remove your Pico. You probably shouldn't. I just wanted to show you that you could. So at this stage, right, I have this guy on here, right? And the next thing I should probably add, you're going to solder in small bits. You're going to try to do the minimal amount that you need to in order to do a simple test, right? Because if you solder everything at once, then if you have any issues, either with the design of your board or with the soldering, like nothing's going to work probably, and you could potentially fry components. So I'm going to add things like one at a time. So I'm going to add the Pico here. But the other thing I need in order to get testing is probably my power source, right? So I'm going to add my power source up there in just a second. So I need to get that part. I forgot to grab that. So one moment. Right, back with the part. Here it is, right? And this guy's just going to drop on there just like that. Now let's use that blue tack that I had before to kind of hold it in place. Actually, staring at this, I think I can probably get away with some blue tack on this side and some blue tack on this side away from the pins I'm going to be soldering, just to kind of hold it all in place. And actually, maybe I should have a little bit more. Split this a bit in half. Put some over here and some right there. There we go. Let's see if this works. Oh yeah, we're good to go. Okay, so I've got that there. Let's add some flux. I might support it from the bottom while I add flux. There we are. All right. Clean off my iron so we can zoom in a little bit more so you can hopefully see what I'm doing. Okay, I'm going to clean off my iron. I've got my solder over here. Now for this guy, these are bigger pins, right? You notice that? So I'm going to try to get in there and really heat everything up. It may take a bit longer for it to get hot. So you notice my solder didn't melt there. Sometimes this happens because we're dealing with a big component with a lot of thermal mass. And that means that the heat I'm applying isn't heating up everything that I want it to be heating up. So I'm going to turn my temperature up on my soldering iron to 700. Sometimes a little bit more heat can help. In general, you don't want to keep it too hot all the time. You only want to heat it up when you need it, because if it's too hot all the time, it actually speeds up the oxidation process on the tip. And if the tip gets oxidized, then it's useless for soldering. So heat that sucker up to about 700. Okay, I think I'm there. And let's try this again. Okay, there we go. Boom. Got it. Let's do another one here. Once again, remember, I'm heating up from the opposite side. I'm trying to get the solder to flow. There we go. And a little bit of junk there. Let's get that off. This one could be more of a challenge. See the direction here? If I go in from here, I don't want to overheat the wrong pin. So I might just spin this whole thing around. Okay. And that will let me heat from this side. There we go. Okay. Now as I take a look at this, oh no, I kind of feel like, so the DC barrel jack is a little bit of a structural component. A good way for me to say that. Like it's something that needs to handle weight properly. So I'm going to move that up and let's zoom down a little bit more again. See if that'll zoom in for me. Oh, yes. Okay. So I'm going to make sure that I have some good solder in there. So add some more. Just because that solder is going to help hold the jack in place as I like plug and replug things into it. Okay. Boom. That seems pretty good. I'm happy with that. Now, if you look, you can see on the board, it's like liquidy residue. That's the flux. It's leftover flux. So we will talk a little bit about how you can clean that off. But for the most part, the kind of flux we're using is what we call non-conductive, which means that it shouldn't being the operative word there, impact the electrical connectivity of the circuit. Now that isn't always the case. So sometimes for whatever reason it does. I'm not fully sure why non-conductive solder does end up conducting occasionally. So sometimes it's helpful to clean it off. And in that case, you just use an old toothbrush and a little bit of rubbing alcohol and you can wipe it right off and then just let it dry. But we'll talk about that a little bit in lab. Okay, so we've done some basic soldering there. I've demonstrated the importance of the blue tack, right? Actually, let's zoom that out a little bit. Flip this over and I'll remove my blue tack now. Just remind myself that I don't need it anymore. And now this thing is like, it's quite a solid little connection. Okay, so I've soldered on a couple of different components, right? My board has a lot more than yours does, but like, that's okay. So I've soldered on a few different components. What I'm gonna do next is I'm going to plug on my microcontroller, right? Make sure I have it the right way, because there's nothing that's going to keep you from plugging this in backwards, and that would be bad. And then I'm going to take it over, I'm going to power it up, and I'm going to make sure that if I apply power at the barrel jack, that it properly goes here. Now, the other component you'll need to add to yours is a diode. The board I'm having here already has one mounted on this. It's a surface mount part that I'm experimenting with, so you will have to add your diode as well. When you add the diode, make sure it's facing the right way. Remember, diodes have polarity. If you have it facing the wrong way, nothing's going to work. And you really don't want to have to remove a part that you've already added. That is doable, but very, very annoying. So I recommend you try to avoid that. So before you solder on a part that has polarity, like quadruple check that you have it the right way, right? Don't just be like, oh, it's probably fine. It might be fine, but you might have issues. So yeah, double check that, triple check it, then check it one more time just to be absolutely confident. That's probably enough to get you started on soldering. Remember the important points here. Wear your safety glasses, right? Turn on your air filter so that you have that thing running, right? This guy here, right? Set your soldering iron for about 650 for most soldering, right? And you can pump it up to 700-ish if you need to on a component that's got more metal to it and you can't get much on there. Make sure your sponge is damp, not wet. And now, last tip here, and this is important. When you are done for your time and you're gonna like put it all away, right? You need to turn off the soldering iron, click, right? And then you're going to tin the tip one more time, which is where we're just going to add some solder on there. So I'm just going to melt some solder onto the tip. I'm going to try to kind of get it all over the end of the tip there. And the purpose of this is to protect the tip from oxidation. Oxidation, that's the word. Protect the tip from oxidation. So I'm going to go ahead and do that. And now with the iron off, it will slowly cool down. But remember, that thing is still super hot. So like when in doubt, don't like touch it in here. Like that's really hot. So that's all for now. Thanks a lot.